How do you extract high-purity caffeine? This tree has a bag of wild coffee on it, so we can use it for extraction. Prepare a beaker and an electronic scale, and first add 20 grams of steel-cut coffee powder into it. If you don't have any, you can buy some, or you can use tea leaves instead. Then add 10 grams of baking soda, which helps some compounds dissolve better in water. After shaking it well, add 5 times the volume of distilled water compared to the coffee. Turn on the computer and cook it for a few minutes to heat it up, stirring at the same time. I took a picture of the bubbles on the upper layer. Now it is basically a cup of very concentrated coffee. There are a lot of dregs, which need to be filtered out. I used coffee filter paper to do a simple medium grain filter to 28 points. The effect was really similar. After filtering, I got a cup of relatively clean and caffeinated experimental grade coffee. The next step requires us to move outdoors. Make sure to wear a gas mask and set up the funnel properly. Pour all the filtered coffee solution into it and add 25 milliliters of dichloromethane. Caffeine is much more soluble in dichloromethane than in water, but it is toxic, so you need to take safety precautions while operating. Remove the sieve and gently shake it. Be careful not to shake it too hard, or the emulsion will be difficult to separate. Also, remember to occasionally open the valve to release any gas that builds up. Put it back on the stand and let's check the layers. The lower liquid is the caffeine dissolved in dichloromethane. Open the tap and pour it into the beaker. It's not too much at once, so we repeated the same washing step 2 more times, resulting in about 80 milliliters of caffeine extract. However, it contains some moisture, which makes it look cloudy. Prepare a saturated salt solution and use it to wash the extract. See? It's already much clearer. Gently shake it again, and after it separates, pour the solution into a beaker. The color looks a bit yellowish, so let's heat it up on an electric heating plate to remove the dichloromethane. The temperature doesn't need to be too high, because the boiling point of dichloromethane is quite low, around 40 degrees Celsius. After 2 hours, there's still some residue at the bottom of the cup, which smells really nice. It might be the essential oils from the coffee mixed in. But this isn't good enough. It's clearly not pure, so we need to recrystallize it to further purify it. The beaker containing the impure caffeine is placed on the heating plate. Heat it up while slowly dripping in high concentration ethanol. The goal is to dissolve as much caffeine as possible in a small volume. By heating it like this, you can dissolve more caffeine. Once everything is dissolved, transfer it to a surface and let it cool slowly. As the temperature drops, caffeine starts to become less stable and vaporizes from the solution to form crystals. Most of the impurities remain in the solution and can be separated by filtering. Put it in the refrigerator for a few hours with the cover on so that most of the caffeine has recrystallized into beautiful needle-shaped crystals. Pour it all into a vacuum filter and turn on the vacuum pump to filter. You can observe that there are still some impurities in the high concentration ethanol that has cooled in the fridge. It won't damage the precious caffeine, so just drip it slowly to clean it up. Everything is going smoothly. What's left here are some very clean caffeine crystals, but it's really a small amount. I shook it, but it just won't come out. The experimental product is not for tasting. It's very bitter. In the end, we only harvested about 60 milligrams of high-purity caffeine, which is even less than the caffeine content in a cup of freshly brewed coffee. It's not just a central nervous system stimulant that can temporarily ward off sleep. It's also a natural pesticide that can paralyze insects that feed on plants containing caffeine.